Hello everyone, this is Anita, Assistant Professor from Department of Artificial Intelligence and Data Science from Ramco Institute of Technology. Today we are going to discuss an important topic in database design, which is the ER diagram into relational mapping. Before going into the conversion process, let us first understand what an ER diagram is. Okay, an ER diagram is also known as the entity relationship diagram, which is the conceptual model that used to represent the real world data. Like it shows an entities, their attributes, and the relationship among those entities in a visually understandable manner. Okay, so however, but ER diagram cannot be stored in a database format like in the form of tables. So, to actually store the data into a database, we must convert the ER diagrams into relational tables. Okay. In this lecture, we are going to learn how an ER diagram is converted into relational tables. Okay, this is the course outline. In this video, this is what we are going to cover. First, we will learn the six rules that we are going to apply in an ER diagram, and we are going to convert that into a relational tables. I will explain all the rules in step by step process, but we apply all those rules in an one single ER diagram, so you can completely clearly understand how the conversion is done. Finally, we will arrive at the final relational schema where all the relationships and the entities of the ER diagrams are converted into a proper table. Okay, on the screen you can see a simple ER diagram of a student entity. Here, student is the entity and it has the habit attributes like student ID, age, and name. These are the attributes of the student. Okay, so among these attributes, student ID is the key attribute. It uniquely identifies the each student. So the student entity is converted into a student relational table. So all the attributes become a column of the table. This is the basic idea of ER conversion. Okay, so entities become a table, attributes become a column, and the key attributes become a primary keys. So this is the concept of the conversion of this process. So next we will see the rules of the conversion process. Okay, now let's look at the overview of the six important rules. Okay, first we will see how the entity sets are converted into relations. Then we will understand how the independent entities like simplified entities are converted during the conversion process. And rule number three, we will see how the complex attributes are simplified before storing them into a table. And the next rule is the mapping of multivariate attributes like storing a multiple values into a simple separate relations, and then we will see how the relationships are represented using that those keys. And the sixth rule is the many to many relationship, how these many to many relationships are converted using the new relations. So in this upcoming slides we will take only one example like complete ER diagram and converted into a proper relational tables. Okay, now let's start with the rule number 1. In this rule, each strong entity is converted into a separate table. All the simple attributes of this entity become a column in the other tables. Like key attributes are used as a primary key. On this screen, you can see an ER diagram with entities like student, department, course, and student details. This is the example diagram that we are going to use in this entire video. So we will apply the rules as one by one in this diagram. So now on the slide, so see you can see the relational tables created from the ER diagram, right? Each entity is converted into a separate table and all the attributes are shown as the column inside the table. Like for example, the student table kit contains the attributes like student ID, name, and age. The department table contains the name like department ID and the department name. So likewise, the course table also contains these attributes into a column in a table. Okay, so the first rule is successfully applied. So now let's go to the second rule. The rule number 2, the weak entity is converted into a separate table. As you can see in the diagram, the student detail table depends on the student entity. So while creating the table, we must include the primary key. which is the primary key of the student table, along with the partial key of the student details table. So these two keys were together forms the primary key. Okay, so this is how the weak entities are converted into a relational tables. And now let's look at the rule number 3. Okay, rule number 3, which is a composite attribute mapping. Here, a composite attribute mapping is broken into a simple attribute. Like in this example, see, address is a composite attribute which is simply divided into a street and city. Okay, address can be divided into a street, cities, and areas likewise. Okay, so while creating the table, we do not keep the composite attribute. So instead, we have to add each simple attributes as a separate column. Okay, so in the student table, see, street and cities are added as a column here. Likewise, the attributes were added as a column. The student table, the composite attributes are separated and splitted into a separate attributes into a column. Okay, now understand this rule. So let's go to the rule number 4 here. Rule number 4, which is a multi-valued attribute mapping. When an attribute can have more than one value, we cannot store that in a same table. Like the phone number can have alternate phone number, but we cannot store that in a same column of the table. So in this example, phone number is a multi-valued attribute of the student table. Okay, so we are going to create a new table called student phone. Okay, in this table we include the primary key of the student like student id and the phone number of the student details attributes. These two together form the primary key of the new table. Like student id plus phone number, these two becomes the primary key. Okay, so this is how the multi-valued attributes are converted into a separate tables. Okay, so now clear. Let's go to the rule number 5. Rule number 5, mapping of binary relationship using foreign keys. Like, see the example diagram. In this example, there is a relationship between the student entity and the department entity, like belongs to. This is the relationship. Okay, one department can have many students, so this is the one to many relationship. In this case, we take the primary key of the department table. Like department table, what is the primary key? Department ID is the primary key. So we take that department ID and add that department ID into the students table. Like see this example, student ID is the primary key. So we get the foreign key, department ID from the department entity into the students table. Okay, so this is the act of this rule. This is how one to many relationship are represented using this foreign keys. Okay, so now the fifth rule is clear. Like we have to use the parent's primary key as the foreign key. So the next rule is sixth rule, which explains the mapping of many to many relationship using a new relations. In this diagram, see, we have two entities like student and course. Okay, a student can have many courses and a course can have many students, so this is a many to many relationship, so it is shown as the mstn. So see, we cannot map it directly into a table. Okay, this is a many to many relationship, so we have to, according to a rule number 6, we have to create a new relation. Okay, what is a new relation? The new relation is enrolled. So we have to create a table called enrolled. Now we take a student ID from the student table and the course ID from the course table. We have to add these IDs into a enroll table as a foreign key. So these two becomes a combined together and forms as a foreign key. So separately we can't act this as a primary key. Okay, so we are combining these foreign keys and becoming them as a primary key. So if the relationship has many attributes such as like a credit, so they can also store it into a intro table. So finally the many to many relationship become a conversion of student course and intro table. So this is how the rule number 6 is applied, like including the primary key of both entities as a foreign key. Okay, so together they form as the composite primary keys. Okay, so in this slide we have explained how this rule number 6 is implemented. Okay, now let's look at the final relational schema. In this slide, the entire ER diagram is converted into a relational table by using those 6 rules as applied. First, see the student table. It has the attributes of student ID, name, and age, and address, and the department ID, which is get it from the department table. Okay, so the next table is department table, which contains the department ID, department name, and the department ID is the primary key of the table. So next one is the course table. See the course table, course ID, course name, credit name, and the course ID is the primary key of the table. And from the many to many relationship, we have created a enroll table. See the enroll table center here. So it has the student ID, which is the foreign key of the student table, and the course ID, which is getted from the course table, and the credit and the primary key, which is the student ID and course ID, the together become the composite primary key. Okay, so let's look at the student table here. It stores then additional information like it stores a student ID, extra info, plus these two become as the composite primary key. Okay, so the next last table is student phone. Here, the student ID and phone number together forms as the composite primary key. Overall, this is the relational schema. It uses the primary key and the foreign key correctly. So, it also follows the normalization rules. Finally, the ER diagram is successfully converted into a relational schema. So, we have applied all the 6 rules that we have learned, and the implementation is successful. Thank you. Thank you for listening.